Hi, in this lesson, we'll use these two questions to understand how to find the distance between 2 points. With the first question, we will see how to actually calculate the actual distance between 2 points. And with the second question, we'll see how to calculate the midpoint between 2 points. So now, let's get started. My first question says, find the distance between the following pairs of points. I have T at 6 and minus 7 and V at minus 5 and minus 3. I would like to call T my 1 and call V my 2. So I'll label T here as x1, here as y1. Then for V, my minus 5 will be x2 and my minus 3 will be y2. Now let's get our Cartesian coordinate. Now, in building the Cartesian coordinate for this particular expression, I have my y-axis and I have my x-axis. On my x-axis, I have 6 and I have minus 5. Here is plus 6, here is minus 5. And here is a mark 0. And on my y-axis, I have minus 7 and minus 3. Let's label this point minus 3 and let's label this point minus 7. So that my first point T is at 6 to minus, is x on minus 6 and y is minus 7. So that I have it, this is point what? Point T. That's at 6 and minus 7. And for my point V, I'll have point V at x at minus 5 and y at minus 3. So this is minus 5 and minus 3. Now let's join, here is it. So that if this is my point X, if this is point V and this is T, I can label this line, let's call this line VT. So that I have it this way, forming my triangle, my right-angled triangle. Now, if you missed our first lesson, where we explained how to find distance between 2 points and how to derive the formula for finding distance between 2 points, kindly look into the description below. I have placed a link to that lesson. Now, for the formula for distance between 2 points, we have that D is equals to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So from this expression, you see that our x2 is minus 5, so that my D now will be equals to the square root of minus 5 minus 6 all squared plus minus 3 minus 7 all squared. So that my D now, which is the distance, will be equals to minus 5 minus 6, that's the square root of minus 11 all squared plus the square root plus minus 3 minus 7. Minus 7 becomes plus 7. Minus 3 plus 7 becomes 4 all squared. So that D now will be equals to the square root of 11. 11 times 11, that's 121, plus the square root of 16, plus the square root of 4, plus the square of 4, that's 16, which is equals to 121 plus 16, 137. So that my D is equals to the square root of 137. 137 is an irrational number. You can just look up that in your square root table. Now let's see the second question. For our second question, we are to find the midpoint of the lines joining the following pairs of points. Now the line is joining, let's go to our Cartesian coordinate once more. For our Cartesian coordinate, this is the middle, we mark it 0. Here's our y-axis and here's our x-axis. For my x1, I have it at minus 2. And for my x2, I have it at minus 4. For my y1, I have it as plus 5. And for my y2, I have it at minus 3. Now, if for minus 2 and 5, which is G, we have it here. Yes, minus 2 and 5, that is G. And for minus 4 and minus 3, we have minus 4 and minus 3. We have it here. That's minus 4 and minus 3. Now let's join both points together. Obviously, this is a line. Now we have to find the midpoint of this line. For me to get the midpoint of this line, the midpoint of this line will definitely be a specific point along this line. Now, for me to get the midpoint, we're going to be dividing the axis by 2, so that the midpoint of GH will be given as x1 plus x2 over 2 and y1 plus y2 over 2. So that my x1 is minus 2 plus minus 4 all over 2, and for the y-axis, I'll have 5 plus minus 3 all over 2. That's the same thing as minus 2 minus 4, that's minus 2 minus 4 over 2, and 5 minus 3 over 2, which is the same thing as minus 2 minus 4, that's minus 6, minus 6 over 2, that's minus 3, and minus 5 minus 3, that's 2 over 2, that's 1. So with this, I believe you understand how to find midpoints of a line, and also how to find the distance between 2 points on a line using the distance formula. Thank you and have a nice day.